Hello everyone. Today I'm going to show you exactly how you can take your sprite sheet that you downloaded online and turn it into a working animation inside SFML. Specifically for this video, we're going to be using SFML 3.02, I believe, or 3.2, something like that. But the steps should be quite similar for other versions of SFML. And the first step, what you want to do is go ahead and download a sprite sheet that you like from the internet. Today we'll be using this cat PNG sprite sheet. There's many different animations. Um, and for example's sake, we're probably going to do the tail wag sit front. It's a cute little animation. And if you can see here, all the frames in that animation are laid horizontally. So we have, apologies, let me go back in. We have 3, 4, 5 different frames for this animation. And the idea is after a certain amount of time, we are going to cycle through each of these frames and loop back to the original frame and continue doing that in our program, and it will look like an animation like effect. All right. Now, how are we going to accomplish this? Well, first of all, we need to have this texture in our project. As you can see, I've put our cat PNG into our project. And this code that I have here is just some example code that I got online. It just starts up a window, clears it to black, displays it, sets an event to close, it polls for events. Everything's normal right here, nothing too out of the ordinary. Okay. What we want to do is we want to first create an SF sprite. We can call this a cat. If you look in the constructor, there's a couple of constructors, but we're going to be using the one that takes in a texture by a reference, okay? And this means that we need to first create a texture for our sprite cat, which we will do here, SF texture. This will be a constant texture because we don't expect this to ever change. And we will call it text. And in here, it has many different constructors. But the one that we will be using, you will just pass in a file path, which we will call cat.png. Okay. And now, however, you could go and, okay, pass in text here and all is good. But I don't actually recommend doing this because SFML says that passing in a file path like this straight to the texture constructor can result in undefined behavior. What I recommend doing, sorry, I just ran the program by accident, right? What I recommend doing instead is not making this a const. And then, okay, let's give it a bit more of a descriptive name like cat texture, okay? Or I should actually call it cat sprite sheet, right? And then we can call our cat sprite sheet dot load from file, okay? And then pass our file name over here. And because this returns a Boolean of whether it's actually successfully loaded the file or not, we can put this in an if and not like this, and you can handle the error over here. All right. And this basically tries to load the texture from the file, and if it can't do it, it will handle the error here. You're now avoiding that undefined behavior that I spoke about earlier. Please just do this. It probably will work if you put in the constructor initially, just the path, but this avoids future headache that I've had to deal with in the past, where you're trying to debug some memory issue somewhere, and it's a pain, all right? And now, since this texture is loaded, we can go ahead and pass it to our cat. And there we go. We should probably set our cat's position to something sensible, like let's just say 100, 100. Right, there we go. And don't forget to draw your cat, which we will do over here. Let's run it and see what we have. Okay, apparently we do not We do not have a cat, so let's check and see if this is actually oh, what am I doing? Error, right? std and line. We will need to include iostream. Look what I've done. Okay, let us debug this and see. All right, well, it is loading successfully. Okay, so our sprite is getting this texture in. Question is, why is it not displaying? And I just realized that we have we have put it before the window clear. So what's happening is we're drawing the cat and it's immediately clearing the window to black. So yeah, that's not what you want, right? Like definitely not behavior that we would want. All right. As we can see, our sprite now has the sprite sheet, but it's not even close to what we want, right? Like it's not working out. So what do we do? Well, the first step is on our individual sprite sheets, each of these frames have their own XY coordinate and width and height in terms of pixels, okay? Lots of sprite sheets will have the same amount of width and height, but it might vary per frame because a certain frame might have more information and be a bit wider. So you cannot always be certain. So, okay, if we need to get the exact rectangle bounding this frame, aka the XY position and the width and the height of this individual frame, how are we going to do that? Well, I'm sure there's other ways, but for me, I have created this sprite sheet tool, pixel tool type thing, where if I run this on our cat PNG, this is a different project now, just to be clear, you will see that we are presented with all of our sprites on the left and this little rectangle all the way onto the left, which we can move around with our keys. And if we move all the way around, or all the way down, sorry, to, I'll just give it some bit of time. We have tail wag over here. What does it say? Front. Tail wag front. I believe this is the one that we're looking for. And yes, it is. Okay, and now we can sort of, you can see our sprites showing up on the right-hand side, and it only displays what's currently in our rectangle. So we can move our rectangle around. There we go. And increase the size of our rectangle. Sorry, the width. Now we're increasing the height. And if you see over here, there we go. Okay. There we go. We have our first image of our sprite perfectly in frame. And the console gives us the position of 320, 1, 2, 3, 2, which we will go and note down in the other program. Okay. We are going to make SF int rectangles. I'm not sure what I'm doing. And this one we'll just call it frame 1. And it takes in an int rectangle, which is of the form like this. We consider that points, comma. This first one is the XY position, which we notify as 320, 1, 2, 3, 2. 320, 1, 2, 3. Sorry, I'm not typing. 320, 1, 2, 3, 2. Next one is the width and the height. 28, 32. 28, 32. And that is our frame 1. Great. We did note down that our picture has 1, 2, 3, 4, 5 different frames. So we are going to have 3, 4, 5, 2, 3, 4, 5 different frames. And right now, let's just align this a little bit better. Okay. Great. Now we go back to our tool and we go move on to the next frame. And there we go. I believe none of these whiskers is being pulled off. So this one is 384, 1, 2, 3, 2. So these are probably always going to be the same, but let's just keep going. 384, the size is exactly the same, 2832. Great. Next. This is the next one. We have 448. 448. Okay, next we have 512. 512. And lastly, is this whisker getting cut off? Yes, it is. Okay, there we go. 576. 576. Great. Now, just a quick side note, if you guys want me to actually have a video where I show you the Sprite sheet pixel tool and go through it and post the code somewhere so that you can use it, just let me know. It's very useful. I use it for most of my projects. To note that for this cat, they are probably equally spaced apart. So you could do some loop to update these frames, but not every sprite sheet is like that, and you would need to use the tool, especially if you have something like a tile set that contains many tiles and you're trying to choose a specific tile from there. That sprite sheet tool will become very handy. Okay, we now have all our frames. So let's create a vector of int rectangles. Okay, and we'll call it all frames. Okay, simple. And for all frames, we are going to push back frame 1, and we are going to do that for 2, 3, 4, 5, 3, 2. Okay, there we go. So what do we have now? We have our cat that currently has the texture for the entire sprite sheet, and we have all our frames recorded in these int rectangles. We have now pushed them all to this vector of frames. Now all that's left is to decide which one of these rectangles to render for our cat and when. All right? And how will we do that? Well, we need some form of current index for our vector, which we will make an unsigned int. We'll just call it index, and originally that is going to be index 0. Okay. What else do we need? Well, we need a animation, anim timer. Okay. And this will tell us how much time has passed since the last animation change, so we know if it's time to switch to the next animation or not. Okay. And now how do we actually record that time? Well, there's a handy little thing called an SF clock, right? And this is SF clock. We can simply inside this while loop, we can say clock dot restart. But as you can see, this restart returns an SF time, which returns the elapsed time and leaves the clock in a running state. So what we can do is we can get it as seconds, okay? And we can record this. As you can see, seconds returns a float. So we can record this as a float const delta time. Okay. And this should give us the elapsed time inside this actual frame, which we can then append to our animation timer, continuously append, and try to see is it the next, let's say, iteration for the next frame. All right. So we have the delta time. Now over here, what we need to check is if delta, well, okay, sorry. First we will say animation timer plus equals delta time. Okay, so we're incrementing our animation timer by this delta time. And then we're going to say we should actually have another variable called float const, and this will be anim speed, let's say. And we will have, for right now, a 1 second animation speed. So we have now added this delta time to animation timer, and we're going to check, is our animation timer greater than or equal to this animation speed? AKA, has enough time elapsed to where we need to change our frame, let's say, okay? And if it has elapsed, first thing we need to do is reset our timer back to 0, okay? And then what we are going to do is we are going to simply increment our index, because this index will tell us which animation to load at the time. But you will take note now that we cannot just continuously increment this, because what happens if we go out of bounds? So we can have a little if here and say if the current index is equivalent to our vector of, what was it called again? All frames dot size -1, meaning it's at the max amount of size right now. We cannot just increment it. We can put it in an else. Sorry, we'll put this increment in an else. Okay. We cannot just increment it now. What we need to do is actually reset it back to 0. All right. This is saying if the current index for our frames is on this last index, index 5, don't just incrementing it, because that will push the vector out of range. What you should do instead is loop back around to the original index 0. All right? Makes sense? And now that we have our index, finally, what we will do is we will take our cat object. We will set the texture rectangle. And what this does is, as you can see, it takes in int rectangle, very convenient. And it will say on that sprite sheet, which rectangle should I render for my cat? And in this case, we're going to look at all frames and at position index. And we are going to render that. Let's have a look how this looks like now. As you can see, his tail is wagging, but it's kind of slow. I mean, 1 second delay is a bit ridiculous. So let's actually make it 0.2 so he gets a bit of a quick wag. And also, we are going to set the scale a little bit higher so that our cat is a bit more visible. So let's do that. Let's make it 3 times as large, and let's run it now. And there we go. His tail is wagging. Again, maybe a little bit too slow, right? Maybe a little bit too slow. So let's go 0.5. Should be pretty quick now. And there we go. He's got a really quick tail wag. Okay. And this will continue to just run and update its animations. And in a real project, you'd have your own cat class and handle all of these types of animation effects. But this is the general idea of how you can animate something in SFML. It's very easy and it doesn't take a lot of time at all. And once you have the sprite sheet tool and working out the rectangles, it makes it super simple. Okay. If you enjoyed the video and you'd like to see more SFML tutorials, please drop a like and comment down below to give me some ideas. Maybe you'd like to see a current game that I'm working on, the code for that. Just let me know anything that you're interested in, more tutorials, etc. I hope this was helpful, and until next time, see you guys again.